This next lesson is going to tackle something called the compound inequality. And when I introduce this in my classes, I focus for a little bit on the word compound. And I ask my students, like, what do you know about the word compound, as in like a compound sentence in English class? And most of my students do know, like, a compound sentence is a sentence that like brings two different ideas or thoughts or sentences together with some kind of conjunction, like an and or a but, and you merge two things together. So we could say, like, I am recording this at home. I am recording this on a Thursday afternoon, both of which are true. And so we could combine those two sentences into one and say, I am recording this at home on a Thursday afternoon, and it is a Thursday afternoon. You could write it as one sentence. A compound inequality is similar. So you got the idea of taking more than one inequality and merging it into one. Now, there are two main varieties of compound inequalities. And most of the time when you see these, it's going to be in the context of absolute value. Now, in this video series, I did not address absolute value equations. That is often introduced in an Algebra 2 class. You can do it in Algebra 1. It's definitely within the realm of things that you could cover. But I just didn't go there with this video series and tried to focus more on the linear stuff. But compound inequalities, you will see that when you turn absolute value equations into absolute value inequalities. So the goal for this lesson is to introduce you to the idea of the compound inequality, and then in a future class, you will see these when you're solving other kinds of problems. And so you'll start the other problem and then it's going to end up here, but you'll be in good shape because you'll already know how to do it. So the first kind of compound inequality looks something like this. I'm going to do this visually on the number line. So you might have the number 0 and the number 4. And this type of inequality might look something like this, okay? So it's all of the numbers in between the 0 and the 4, including the 0, but not including the 4. So the numbers would start at 0, and it could be any kind of decimal, fraction, integer. You don't want to restrict yourself to just integers. And then it would hit the 3, and we do like 3.1, 3.2, 3.9, 3.999, 3.9999999. You get the idea, but not the 4. So the 4 is the boundary, and but everything up to that. And the way we would write this as an inequality, and we'll just stick with the number x, okay? We would say that the 0 is less than or equal to the x, and x is less than 4. And what we do is we end up with one inequality that actually comes from 2. Now, if you studied set theory, which doesn't always get hit in Algebra 1. One year that I taught Algebra 1, we had to start the year with set theory. And so if you were to look at it with set theory, so bear with me here. You'd have the 0, you have the 4. The first inequality is basically x is greater than or equal to 0, which is, you can see that right here. So the x is to the right, and you can see it here, x is greater than or equal to 0, and it's all of that. The second inequality is x is less than 4, which would be all of that. And what we're taking is where they overlap. Okay, and so it's what we call the intersection of the two sets. It's where the two inequalities overlap each other. And we could say it this way. We could say x is greater than or equal to 0 and x is also less than 4. And that word "and" means that we're taking the intersection. And that's just really awkward to write. And so we usually don't do it with the different colors, because that's like a little confusing to have like the red and the blue, because all we're really interested in is where they overlap, which is starting at the 0 and going up to the 4. Okay, so I usually don't even say that in my classes. It just kind of introduces another element. If I kind of lost you on that part, you can kind of ignore the last part. You can do the problems just fine without thinking of it as the overlapping of the two sets. So that's the first kind of inequality. And I like doing it this way. Sometimes my students really want to do it that way. With the two different ones, but I like it this way because you can see it on the number line and you can see the number line actually mirrored in the inequality with the 0 on the left, the x in the middle, and the 4 on the right. And you can see that the x is in between the 0 and the 4. And so we would read this: 0 is less than or equal to x is less than 4. Okay, so that's the first type. The second type is this kind. So we might have -1 and we have 2. And x might be less than -1 or x could be greater than 2. Now notice I used a different word in there. I said x could be less than -1 or x could be greater than 2, but it can't be both. This one, you could say and, because it can be both of those things at the same time. In this one, it is impossible for x to be both of those things. And sometimes I'll say to my classes, like, if you think it can be both, I want you to tell me what number. What number is less than -1? So it's going to be the left of -1 and also is to the right of 2. Like, there is no number that satisfies that. So you might be wondering, okay, well, how would you then write that? And you have to write it as two separate inequalities. So the one on the left would be x is less than -1, and then we would put the word or, x is greater than 2, and you actually have to write it in 2. So and again, this is like you could say the intersection, but it's not the intersection. You want to be really, really careful with that. This is a different. This is like an or problem as opposed to an and problem. If we go into sets, it's the union of the sets instead of the intersection of the sets. You don't need to know that. What I like about this notation is that on the number line, it's two separate sections. And when you write the inequality, you have two separate inequalities. This one is one section of the number line, and so you can write it as one inequality. And you can actually see the number line mirroring what the compound inequality is there. This turns up whenever you're dealing with something where you're interested in the extremes. And so, like, if you were taking some really important diagnostic test or something, if you did extremely poorly on it, okay, probably somebody's going to notice, like, wait, what happened? Maybe the student shouldn't be in this class, or maybe their computer malfunctioned or something, like if you're way down at the other end. Or if you did really, really, really well, that's going to catch people's attention. Like, wow, we need to accelerate this kid, or like, what website were they using to cheat? I'm not saying that you're going to cheat, but it's the idea that the extremes are what catch the attention, and everybody else who's kind of stuck in the middle, like, it just kind of goes under the radar and we don't notice it. So if you're wondering, like, what kind of situation would you be interested in, like the extremes, that just gives you an idea. Any kind of situation where you're interested in the extremes, or the extremes would catch your attention. Okay, so how do you solve a problem that gives you a compound inequality? The good news is, like, exactly the same way that you solve other inequalities, because math is consistent and the principles hold true. So let's take a look at this. This is that first kind of inequality, and we would say, -2 is less than or equal to 3x minus 8 is less than or equal to 10. And we're going to solve this, which means that we want to get the x by itself, because solving like that whole strategy doesn't change at all. So we're trying to get the x by itself. We have x being multiplied by 3. We also have a 8 subtracting like the 3x. And just like with solving a linear equation, we need to undo what we did. So we're going to undo that subtraction by adding. We're going to undo that multiplication by dividing. And we're going to do it in the same order that we did it for lines. We're going to undo the subtracting first, and then we'll undo the multiplication. The only thing that's a little bit different is you've got this inequality here. And so it's unbalanced. You got the -2 over here. You got the 10. The 10's weighing it down. Somewhere in the middle here, you've got the 3x minus 8. If all I do is add 8, okay, I run into a problem where I've added 8 to this side, and now it might have tilted this off. Okay, and so we have to make sure that if we're going to add 8, we have to add 8 everywhere. And so this is the only difference. You just got to make sure that you add 8 everywhere you're going to add 8. And you do need to add the 8. So you might say, well, why do I have to add the 8 there? Well, if you like, why can't you just add the 8 over here? Why do you have to add it down here? And the reason why is because when you do some of the other operations, it does affect all of them. And so you need to make sure that you're tracking everything together, because our next step is going to be division. And you got to make sure that you divide everything the same way, because division, especially if you're dividing by negative, can mess with it. So you have to make sure you're working with the right numbers in the first place. So if you're going to undo the -8 in the middle, you have to make sure you add it to the left and to the right so that it stays unbalanced in the same way, and you're not accidentally messing with it or setting yourself up to mess with it in a future step. -2 plus 8 is 6, is less than or equal to 3x. Of course, in the middle, -8 plus 8 is 0, and then I end up with 18. This is multiplication. We undo multiplication with division. And you do want to make sure you're dividing everything. You can't just slash some of it in half. And why you need the right number that you're working with coming from an earlier step. So just remember, when you're doing this, you just got to do it to all the parts. 6 divided by 3 is 2. 3 divided by 3 is 1, and 18 divided by 3 is 6. And so our solution is 2 is less than or equal to x is less than or equal to 6, or you could say x is between 2 and 6, including the 2 and the 6. If you were asked to graph the solution, you can get it right from that inequality. The endpoints are included and everything in between. All right, now suppose you have the other type. This type here where you've got the 2 pieces. All right, so you've got the 2 pieces. So we're going to have 3x plus 1 is less than 4, or 2x minus 5 is greater than 7. Now, most of the time when you see this, it's going to be the same expression in both. It'll be 3x plus 1 is less than 4, or 3x plus 1 is greater than 7. And I think what they were going for here was to try to make sure that the numbers came out nice, which they don't with absolute value. But and pretty much all this is you've got the 2 simple inequalities. You just have to solve both of them. Okay. And so we're going to subtract 1 here. And that gives us 3x is less than 3. And then divide both sides by 3, so x is less than 1. Over here, we'll add 5. So 2x is greater than 12. And divide by 2, so x is greater than 6. And this is an or. X can't be both of those things. So it's either less than 1 or it's greater than 6. And that right there is your answer. There's nothing else to do there. If you were asked to graph it, you should know your numbers. Just going to recommend that first. So x is less than 1 means it's over here to the left of the 1, and greater than 6 is over there. And so that's what the graph would look like. One more example problem before I let you loose to do some problems on your own. And for that, we do need to address, what do you do when you have to divide by a negative? And so we'll do -2 is less than -2 minus x is less than 1. And so here you can tell this is going to be a great time. We've got negatives swarming everywhere, okay? It's going to be fine though. So negative 2 minus x is in between the negative 2 and the positive 1. So that works well. Before we wrap up the lesson, I'll give you a couple like things that you really want to look out for that mean that you've gone astray. We'd like to get the x by itself, and so we need to deal with this negative 2. This is a negative 2, and we can undo that by adding 2. We just have to make sure that we add 2 in all of these places. Negative 2 plus 2 is 0. Please don't panic at the 0. Like, don't panic at the 0. This leaves us with a negative x, and then 1 plus 2 is 3. So, like, 0 is like a real thing. Now, this is a negative 1x, and of course, we don't want a negative 1x. We want a positive x, and so I can get there by dividing by negative 1. But if you think back, dividing by a negative triggers a flip. And all it means is that we're going to flip both of the signs. So 0 divided by negative 1 is 0. Got to turn that around. Negative 1 divided by negative 1 is 1. Got to turn this around. Okay. And notice that it does, and 3 divided by negative 1 is negative 3. Notice that it works. Okay. 0 is greater than negative 3. That is the right, like, that's a true statement. 0 is greater than negative 3. If we look at the number line, there's 0, there's negative 3, it's to the right, so it's greater. This is a very uncomfortable way to write it though, because on the number line, the negative 3 is to the left of the 0, and the way this is written, the way it came out, like the negative 3 is to the right. And so a lot of times what we'll do is we'll just reverse the order. So we've got 0 is greater than x is greater than negative 3. If you were to read it this way, you have negative 3 is less than x is less than 0, which is just a more comfortable way to write it. It just matches up with the number line. It's not more correct, but it does. It's just more comfortable to read. All right, a couple of things to look out for when you're dealing with compound inequalities. Sometimes students will try to write like x is less than 2 or x is greater than 5. And that has to be written in two separate statements because it can't be both. But students will try to write it as both, and they end up with these crazy stuff. So they might have like something like this. 5 is... No, I just did that the wrong way. Like they'll do 5 is less than x, or like x is greater than 5. So they'll do it like this. And then they'll try to put this one on the other side. Except what have we accidentally said when we tried to do that? It's like, oh, this is so convenient. We'll just combine them. Well, if you look at it closely, it says 5 is less than x is less than 2. Accidentally, you have told me that 5 is less than 2, which is not true. Don't do it, okay? If it needs to be written as 2, it needs to be written as 2. And make sure that's confusing because it's got like x there, but here, wrong. There we go. So you can end up writing something that is impossible. I'm trying to take a little shortcut there. Other things to be wary of is anything like this, okay? Or we can go the other way around, and I don't know. Okay? Your inequalities should always be facing the same direction. So this just means something has gone very astray and it's very bad. So you can write them like with the greater than, you can write them with the less than. We prefer the less than. But in both cases, like the inequalities all have to be facing the same way. You cannot write the single statement with the inequalities flipped around. Now, in these kinds, you'll have one that's less than and one that's greater than, but that's fine because they're in two separate statements. It's when you're combining them into one statement that they have to all be in agreement and face the same way. So we'll just Okay, don't do it. So those are just a couple of things that I know I see a lot of, and just want to let you know, like, hey, be wary of that. So on the next slide, I'll go ahead and put some practice problems up, and we'll keep it pretty simple so that you can just practice working with the compound inequalities. All right, for the first two, just solve them. -6 is less than x minus 4 is less than or equal to 4. And -10 is less than or equal to -4x minus 18 is less than or equal to 30. For 3 and 4, solve and graph. And always read the directions. Like, make sure you do everything the directions are asking you to do, but there's no reason to do more than what the directions are asking you to do. So we have 2 is less than or equal to x is less than 5. I guess there's nothing to solve there. Just graph it. -8 is less than or equal to 1 minus 3 times x minus 2 is less than 13. That sounds like fun. And then for the last two, write the inequality for x is between 7 and 4 and x is less than 4 or greater than 9, which is the only one of the second type on here. So pause the video, take a moment to do those out, and then unpause the video to check your work. Okay, here we go. For this first one, I wrote it out, just added 4. Just make sure you add 4 to all the sides there. And we get -2 is less than x is less than or equal to 8. So that's what you should have for the first one. This one ended up being really nice. So I started by adding 18, and you make sure you add it to each part of that. -10 plus 18 is 8. Here the 18s cancel out, leaving you with the -4x, and then 30 plus 18 is 48. Now we're dividing by the -4, and remember, when that happens, you trigger the flip, and so it's got to flip around. -2 is greater than or equal to x is greater than or equal to -12, which is correct, but awkward, okay? Because that's like the wrong order for the number line. And so we kind of turn it around. We just read it the other way around. -12 is less than or equal to x is less than or equal to -2. Like so. Now, what I have over here is just confirm on the number line, which was not required. You did not have to do the graphing, and I made a point of saying that, like, don't do extra work. But it's entirely possible that in a problem like this, you might not feel really confident, okay, that you've done it right. And so if you don't, put the number line on there with the -12 and the -2 so you can see where they are, and it should match up with the statement that you've written. It takes about 3 seconds to do that, maybe 5 seconds to do that, so you can be confident that you flipped things around the right way and it all looks good. Number 3, number 4 makes up for number 3. Number 3 is just graphing it. Make sure that you have a solid circle at the 2 and an open circle at the 5, and x is in between them, so it should look something like that. Now, there are multiple ways you could do this. So there's actually several ways that you could do this. You could subtract the 1 first and then divide by -3 and do the flip and then add 2. Okay, that should work. In fact, I might do it out that way just to show you that you can. This way, I distributed first. So -3 times x is -3x, and -3 times -2 is +6. Then I combined the 1 and the 6. So 1 plus 6 is 7. And then I subtracted 7. Now, this is like, all this was just simplifying what was in the middle so that I could handle it. Then I subtracted 7. -8 minus 7 is -15. 13 minus 7 is 6. And now we're dividing by -3, which is going to trigger that flip. This is a +5 is greater than or equal to x is greater than or equal to -2. And of course, that is an uncomfortable way to write it. So we turn it around. -2 is less than x is less than or equal to 5. This one, you were required to graph it. And so you should have an open circle at the -2, a closed circle at the 5, and shaded in between. And as always, pause the video if that was a little bit much. All right, number 5, x is between 7 and 4. Now, you want to be careful because you might say between 7 and 4, and does that mean you color them? If x is between them, then it can't be the 4 and it can't be the 7, because between strictly means between them. If you wanted to include them, you would say something like x is at least 4. At least would imply that you could have the 4, and at most 7. And so that kind of phrasing would include the circles. And then so this is 4 is less than x is less than 7. And the last one, x is less than 4, or x is greater than 9, and just make sure that you're not trying to combine those into one. I will add one more page here because I do want to work that other problem a different way, just so you can see it. So that was -8 is less than or equal to 1 minus 3 times x minus 2 is less than 13. So you could start by subtracting the 1. Okay, this gives us -9. This is really messy here, but that's 1 minus 1, which is 0, which leaves us with -3 times x minus 2 is less than 12. Then you could divide by the -3 because that's multiplication there. And that division is going to trigger the flip. Negative divided by a negative is going to give us a +3. This -3 divided by -3 is 1 and is just going to leave you with x minus 2. And then 12 divided by -3 is -4. And then we would add 2 to both sides. So we get 5 is greater than or equal to x is greater than or equal to -2. And then, of course, that's in the wrong order, but I don't even think I need, like, the same thing we got here. 5 is greater than or equal to x is greater than or equal to greater than -2. And so it's the same expression, just working the algebra a different way. And this is like one way that teachers will catch students that are copying, because there are different ways to do it. There are different ways that you can navigate the algebra in solving these. And so if you and the person next to you like make exactly the same decisions in every single problem all the way through, that's just not that likely. So hopefully this made some sense to you for the compound inequalities. You will see them in the future past Algebra 1. You won't see them a lot, but hopefully you've got that foundation. There's one more lesson in inequalities, and I'll see you later in that lesson.